Hi, seventh graders. We are going to be discussing probability today. So, as we've talked about over the past few days, probability is the likelihood of an event happening, expressed as a number between 0 and 1. So, any type of number between 0 and 1, and we can write it as a fraction, a decimal, or a percent. So, what we've looked at is we've just talked about some simple probability. So, that is just when one event is happening. And so the probability of a simple event is called simple probability, and it's our ratio of favorable outcomes to total outcomes. And that word favorable just means outcomes that meet the criteria of what you're looking for. Our kind of spectrum for probability goes between 0 and 1, like I said. And so you could be expressing, if I'm asking you for the probability of an event, you want to express it as a numerical answer. So again, as a fraction, a decimal, or a percent, somewhere between 0 and 1. If you're asked for the likelihood of an event, then you can express it in words. So a probability of 0 would be impossible. A probability of 1 would be certain. 1/2 is that equally likely as not. Anything between 0 and 1/2 we say is unlikely. And then anything between 1/2 and 1 we say is likely. So a six-sided number cube numbered 1 through 6 is rolled. What's the probability of rolling a 4? Notice this notation here, the uppercase P, and then in parentheses the 4. So we have the probability of that event of rolling a 4. There's one favorable outcome, that is a 4 out of the 6, so that probability is 1/6. Daisy spins the spinner. What's the probability of landing on A? So here we have 4 outcomes that are all equally likely to happen, okay? And so there's one favorable outcome, that's an A, out of the 4 possible outcomes. A six-sided number cube numbered 1 through 6 is rolled. What's the probability of not rolling a 1 or a 2? That means I could roll a 3, 4, 5, or 6. And so there's 4 out of 6 outcomes that meet that criteria, and I can simplify this to get 2/3. So there's also two types of probabilities. There's experimental probability and theoretical probability. When we talk about experimental probability, this means you've actually done the experiment. You flipped the coin 10 times, you rolled the dice 20 times, you did an experiment, and you have your results. And so it's based on what actually happens in the experiment, and we express that as the number of times the event occurred over the total trials in the experiment. Theoretical probability, this is what should happen, okay, under perfect circumstances. So this would be kind of like our simple probability, just the number of favorable outcomes over the number, the total possible outcomes. So for number 1 here, it says the spinner shown below was spun for a probability experiment. The results were recorded in the table. Determine the theoretical probabilities. Well, we have 4 sections that are all the same size. And so because there's 4 possible outcomes, and favorable outcomes for blue would be 1/4. For red, I have a 1/4 chance. For green, I have a 1 in 4 chance. And for yellow, I have a 1 in 4 chance. So theoretically, what should happen is if I spun that spinner 4 times, I should land on each of those colors 1 time. That's theoretically what should happen, but that's not actually what necessarily will happen. It might not. So over here, we've actually spun the spinner. Our results are in the table. So the first thing we're going to do is we need to look at these frequencies and figure out how many total times the spinner was spun. And so if I landed on each of these colors that number of times, I can add these all up to get, I spun that spinner a total of 20 times. And so now to get those experimental probabilities, we're going to look at how many times I landed on the color out of the 20 times. So for blue, I landed on blue 8 times out of 20. So the experimental probability of landing on blue is 8/20. That can be simplified by 4 to get 2/5. For red, I'm going to look. I landed on red 3 out of the 20 times. That fraction cannot be simplified. Green was 4/20. which I can simplify to 1/5. And yellow, I landed on yellow 5 out of the 20 times, which is equal to 1/4. So part A down here, now I'm going to start comparing and looking at these probabilities. So it says, what is the difference in the experimental and theoretical probability of landing on red? So the difference, that means I'm subtracting. And so I need to look at the theoretical probability of landing on red, which we said was 1/4. And the experimental probability of landing on red, which is 3/20. And so the first thing that I'm going to want to do, since I'm going to need to subtract these, is I need to find a common denominator to be able to compare them. So a common denominator for 4 and 20 is 20. And so if I multiply 1/4 times 5, I get 5/20. So now, theoretically, out of the 20 times, I should have landed on red 5 times. And what actually happened is I landed on it 3 times. So now we can go ahead and we can subtract them to find the difference. And the difference here is 2/20, which is equal to 1/10. Which color has an experimental probability equal to its theoretical probability? So I can look at these probabilities and compare. And yellow has a probability of 1/4 in both of those categories. And what's the experimental probability of not landing on blue? So the probability of landing on blue, experimental probability, what actually happened, was 2/5. And so the probability of not landing on blue, that means if 2 out of every 5 spins was blue, then 3 out of every 5 was not blue. Notice that those two will equal 1 whole together. Brooke has a pouch with 24 school supply items in it. There are 5 markers, 10 crayons, 3 glue sticks, and the rest are mini erasers. What is the theoretical probability of randomly selecting an eraser? So we just want to know what should happen here. So first of all, we know that there's 24 total items. To figure out the number of erasers, then we have to subtract off all of these other items. So we're starting with our 24 items. We can subtract off what we already know. And when we take out 5 markers, 10 crayons, 3 glue sticks, we're going to be left with 6 erasers. So you have a 6 out of 24 chance of drawing an eraser, which can be simplified to 1/4. So you have a 1 in 4 chance of randomly pulling an eraser. Phoenix rolls a die 12 times. The results are shown on the table. Theoretical probability of rolling a 2. It doesn't matter that she's rolling it 12 times. The theoretical probability of what should happen is still going to be 1 out of every 6 rolls should be a 2. So experimentally, what happened? Well, she rolled it 12 times, and we can see that she actually rolled the 2 3 times. 3/12 can be simplified to 1/4. We're not going to worry about part C down there right now. So theoretical probability is what should happen. Experimental probability is what does happen. You could use either of these probabilities to make predictions for future events by setting up a proportion. So we had an entire unit over proportions. We used proportions with percents, and we're going to continue to use proportions with probability. And so once you have your proportion set up, then you can solve it using a relationship or cross products. So here's an example of how you would set up a proportion. So it says predict how many times you would roll a 6 on a die that was rolled 120 times. The first thing you want to do is just figure out that probability of rolling a 6. So if we're talking about a standard dice, your chances of rolling a 6 are 1 out of 6. There's 1 6 on that dice. Okay, we're going to set that equal to a predicted favorable over predicted total. Well, it's telling us that we're going to roll it 120 times. So that's going to be our total. And now we're going to use that information to predict how many of those 120 times should be a 6. So here's my proportion. I have it set up. And then this is where, if you need to use cross products will always work. But I don't think that they're always the most efficient. So in this case, I see that 6 times 20 would equal 120. And so we could do the same thing across our numerators, and if I scale 1 up by 20, I'm going to figure out that x would equal 20. So I would expect to roll a 6 20 times out of the 120 rolls. That doesn't mean that that's what's going to happen. This is just a prediction. Number 5, a bag of marbles contains 6 purple marbles and 4 yellow marbles. If you draw 600 times, replacing the marble each time, about how many yellow marbles can you expect to draw? So yellow marbles, we have 4 yellow marbles out of a total of 10. So I'm getting that number because there are 6 purple and 4 yellow. So altogether I have 10 marbles. So right now the probability that I would randomly draw a yellow is 4/10. Technically that could be simplified, but I don't need to simplify it because I'm just comparing it, and I'm going to use it to help me figure out how many times out of 600 I would expect to get yellow. So here's my proportion for that. You could use cross products to solve here. In this case, I noticed that 10 times 60 equals 600, so 4 times 60 would equal 240. So I would expect to draw a yellow 240 times out of the 600. Lily has a bag containing 35 letter tiles. She selects a tile without looking and then replaces it. Predict how many consonant tiles there are in the bag if she pulls 3 consonant tiles and 4 vowel tiles. So she's done her experiment. So far, she's gotten 3 consonants. That's what we're predicting out of the 7 draws that she's done. Okay, and so again, I'm getting that because there's 3 consonants that she's pulled and 4 vowels. So altogether, she's done 7. She's drawn 7 tiles. So we can use that probability now to make a prediction of how many of the 35 tiles would be a consonant. And so again, cross products would work, but if you notice a relationship, I would encourage you to use that. So I noticed that 7 scaled up by 5 equals 35, so 3 times 5 is 15. So we can predict or estimate that there would be about 15 consonant tiles. Again, these are just predictions. That doesn't mean it's for sure going to happen, but that's a little bit about how we can use probability to make predictions. Have a great day.